So the next problem on the practice exam is a word problem, and I have a basic picture set up, but the word problem says we have this antenna standing straight up, and we have this blue wire connected to the top of the antenna and then connected to the ground. And we're given some information. We have that the wire that's connecting these two pieces is 100 feet long. So we know that hypotenuse there of this right triangle that's formed is 100. Right. It also says that the angle created by the wire and the ground is a 62-degree angle. Alright, so that's the information that's given to us, and from that information we want to know how tall this antenna has to be. Alright, so we're going to introduce some variable. I'm going to call the height of the antenna y. So if we can solve using some trig, we can figure out what y is. We know how tall the antenna is. So right now we have this angle here. We have a side that's opposite the angle and a side that's the hypotenuse of this right triangle. So we're going to use sine, because sine is so, which is opposite over hypotenuse. So if we take sine of this 62-degree angle, right, that's opposite over hypotenuse. The opposite side across from the angle is y, right, and the hypotenuse is this blue edge, which is 100. Alright, so the goal of this problem is to solve for y, which is the height of the antenna. So we're just going to multiply both sides by 100. So on the left hand side we get 100 sine of 62. And on the right hand side the 100s cancel and we just get y. Alright, so on the practice exam it says to leave your final answer in terms of the trig function, so we just leave it here because we don't have an exact answer for what sine of 62 is. We do know that sine of 60 is 1/2, so this answer is going to be a little bit bigger than 50 feet if you want to get a decimal, but for now, for what the practice exam asked, this example right here, or this answer right here, will be perfect. Alright, so the height of the antenna is 100 sine of 62. So problem number 14 wants us to solve this equation here. Right, so we have 12 cosine squared of theta plus cosine of theta minus 6 equals 0. So when we have this equation like right here, we're going to make it look more like a quadratic by replacing cosine of theta with something simpler. So we're just going to call it y, and we're going to say that's cosine of theta. Now the next thing, if we make y cosine of theta, well the first term we have cosine squared here, is going to be y squared. Alright, this is exactly what we called y, so we have plus y, and then minus the 6 equals 0. Alright, so the first step was just to make it look a little bit simpler, and now we're going to try to factor and solve for what y has to be in this more simple equation. So we're going to try to factor it. So if we look at the first coefficient in the constant term, we have a times c equals negative 72, and in the b term, which is the coefficient of just y, equals 1. So we need two numbers that multiply together to give negative 72 and add together to give 1. So the numbers we're going to have to use are negative 9 and 8. Alright, so now we're going to do factor by grouping. We're going to replace this 1y with a minus 9y and an 8y. So I'm going to rewrite this equation as plus 8y minus 9y minus 6 equals 0. Alright, and now we're going to do factor by grouping. We're going to look at these two terms together and these second two terms together. Alright, so from this first term we're going to factor out the biggest thing we can, which is a 4y. Right. And that's going to leave us with 3y there and just a 2 in the second term. And from the second set we're going to factor out a negative 3. Alright, that's going to leave us with a positive 3y here and a positive 2 there. And now on each side of this minus sign in the middle, both these terms, bigger terms, have a 3y plus 2, so we'll factor that out as well. Alright, now this was the 4y here and a minus 3 there. So now we have these two factors of 12y squared plus y minus 6, and of course if we have this piece here multiplied by that piece here equals 0, that means either the left hand one equals 0 or the right hand one equals 0. Alright, and we can solve both of these equations for what y has to be. Here we'll subtract the 2 and divide by 3, and y equals negative 2/3. And here we'll add the 3 and divide by 4, and y equals 3/4. Alright, so we solved this simpler equation at the top for what y has to be, but originally at the beginning we made y equal to cosine of theta. So now instead of y equals negative 2/3, we're going to look at cosine of theta equals negative 2/3. And also cosine of theta equals 3/4. Alright, so now we have to figure out what theta we have to plug in to cosine in order to get out negative 2/3, and what theta we have to plug in to cosine to get out 3/4. Unfortunately, this problem doesn't work out too well because we don't have nice formulas for what cosine of theta equals negative 2/3 or 3/4 are. So for now, we'll just leave it like this. But if you want to know how to solve these type of equations where we have a trig function of an angle equals some value, then look at problem number 9. It's a specific case where it actually works out a little bit better than this problem works out. So now we're on to the last page of the practical exam, and the last thing we have to do is find the exact values, so not decimal approximations, of these 4 trig functions here. So the first one we have to find cosine of pi over 4, but that's something we've been doing for a while. So you know cosine of pi over 4 should be the square root of 2 over 2. So that's just one of our angles that's in the first quadrant that we should know the cosine value of. Alright, so we get that first one almost for free. Alright, now we have to find sine of 120. Alright, so the problem we come up with is that 120 is not in the first quadrant, so it's not this special case like pi over 4 where we should know the cosine and sine values of it. What we're going to do is rewrite 120 as a sum or a difference of 2 angles that we know, and we're going to rewrite sine of 120 as sine of 2 times 60 degrees. Alright, so 120 degrees is the same as 2 60-degree angles, and we have a formula for if we have a double angle inside of sine. And what it is, we're going to take 2 times sine of the simpler angle, so 2 times sine of 60, and then cosine of the same angle. Alright, so this comes from our formula for sine of 2x. We get 2 sine x cosine x. Alright, now we just need to figure out what sine of 60 and cosine of 60 are. So we just need to simplify this as 2. Alright, sine of 60 is 1/2. Cosine of 60 is the square root of 3 over 2. And I said those backwards. Sine of 60 is the square root of 3 over 2. And cosine of 60 is 1/2. Alright, but now the first 2 and this 1/2 cancel. They'll become 1, and we'll just get our final answer, which is the square root of 3 over 2. Alright, so now we figured out what sine of 120 is by using just 2 sine of 60s, or sine of 2 60s. And now we want to find sine of pi over 12 by kind of doing the same thing. So I have the angles that we know in the first quadrant written at the top here. So we want to rewrite pi over 12 as a difference of 2 of these angles. We can't write it as a sum because it's already smaller than these 4 angles here. So we want to write it as a difference. We're going to write it as sine of pi over 3 minus pi over 4. Alright, so pi over 3 is 4 pi over 12, and pi over 4 is 3 pi over 12. So it'll cancel out and just give us a pi over 12 like we want. Alright, so now we need our formula, which says sine of one angle minus another is sine of the first angle, cosine of the second angle. Alright, the same sign in here, so this is a minus, and now cosine of the first angle, sine of the second angle. Alright, so now we just need to figure out these 4 trig values, multiply them, and combine them. Well, sine of pi over 3, we just saw sine of 60 and pi over 3 are the same thing, so that's the square root of 3 over 2. Cosine of pi over 4 we also have from part A, that's the square root of 2 over 2. Right, minus cosine of pi over 3, that's 1/2, we also saw that right here. And sine of pi over 4 is also the 45-degree angle, so it's the same as cosine of pi over 4, so that's the square root of 2 over 2. So now we're going to multiply both these out. Square root of 3 times the square root of 2 is the square root of 6 over 4. And 1 times the square root of 2 is the square root of 2. And again, 2 times 2 is 4. So we get square root of 6 over 4 minus the square root of 2 over 4. They already have a common denominator, so we can combine the numerators as the square root of 6 minus the square root of 2 over 4. So this is the exact value for what the sine of pi over 12 is going to be. If you were to put this in a calculator, you'd get some type of decimal approximation. You want to have the exact answer with the square roots that we want. So now we're going to move on to part D. We want to find cosine of the 75-degree angle. And again, we're going to write cosine as a sum or difference of two angles, where we have the 30-degree angle and the 45-degree angle, and we're going to write this as cosine of 30 degrees plus 45 degrees. So we know the 30-degree angle plus the 45-degree angle gives us 75. Alright, but now we have an identity for the sum of two angles. So we take cosine of the first angle, cosine of the second angle. Alright, and then there's an addition in here, so there's going to be subtraction there. Now we take sine of the first angle, sine of the second angle. Alright, and again, we just have to figure out what each of these values is and combine them to get our answer. So cosine of 30 is the square root of 3 over 2. Cosine of 45, we just saw down here, pi over 4 and 45 are the same thing, so this is square root of 2 over 2. Sine of 30 is 1/2, and cosine of 40 or sine of 45 is the same as cosine of 45, which is square root of 2 over 2. And now this expression here is the same as the expression that we found for sine of pi over 12. So now this is going to simplify down to the square root of 6 minus the square root of 2 over 4. Alright. So if you can write your angle as a sum or difference of angles that we should know in the first quadrant, you can find the exact value of its sine or its cosine.